Hey guys, I'm just going to go over a quick video, going over a couple of things just to make sure everybody's on the same page with lesson two. And I'll be posting some things about lesson three as well, but I wanted to at least get through some of the problems, and I'm going to go ahead and do that now. All right, guys, so you'll remember your job is to get through the numbered problems. So I'm actually going to cover the main problems here just to make sure we're all on the same page. So let's take a look at problem 521. So we've got that secant squared x cotangent squared x minus 1 is equal to cotangent squared of x. So once again, basically, if we've already done this problem, I'm sorry, but I can't remember exactly what we did. So let's walk through this. The first thing I'm going to do is turn everything in terms of sine and cosine. Might make things easier for me. So this ends up being, let's see, 1 over cosine squared x, not theta. So we use this correctly, times cosine squared. I really want this to be theta apparently. But cosine squared x over sine squared x minus 1 is equal to cotangent squared x. All right. So at this point, the cosine squareds cancel, and you're left with 1 over sine squared x minus 1 is equal to cotangent squared x. But 1 over sine squared x is really just cosecant squared x minus 1 is equal to cotangent. And at this point, you could literally stop because this is a Pythagorean identity. But if you wanted to go further, you could say cotangent squared x equals cotangent squared x. All right, the next one we've got is we got tan squared of alpha is equal to secant of alpha, cosecant of alpha, tangent of alpha minus 1. So we think about it, basically this is 1 over cosine of alpha, 1 over sine of alpha, and sine alpha over cosine of alpha. And then it's all minus 1. So basically the sines will cancel, but you'll be left with 1 over cosine squared of alpha minus 1. 1 over cosine squared would be secant squared of alpha minus 1, which is indeed tangent squared. Once again, this will be a great time for you all to practice, making sure that you are familiar with all of the identities we've covered thus far. So for problem 523, we've got 1 over cosecant x plus cotangent x plus 1 over cosecant x minus cotangent x, right? And this is all equal to 2 cosecant of x, supposedly. We're about to find out. So the way I like to add fractions is kind of that cross multiplication. So I'm going to multiply the denominator with the numerator, the two denominators together. So you end up with, let's see, cosecant x minus cotangent x plus cosecant x plus cotangent x. And then if you multiply the two together, this is the difference of squares. So you end up with cosecant squared x minus cotangent squared x. Now, the good thing about that stuff in the denominator is it's just 1, right? Because, you know, cotangent squared plus 1 is equal to cosecant squared. So if you subtract the two cotangents, you get 1. So the denominator is basically 1. In the numerator, we have negative cotangent. We'll cancel the cotangent, and you can finally see that 2 cosecant of x is all that's left, which is exactly what we wanted up here. 524 is very similar. All right, let's look at 525. With 525, this one is a little bit trickier, but you could go in two directions here. All right. So the first direction I want to go in is I'm going to use sine of alpha minus 1 minus cosine of alpha is equal to cosecant of alpha plus cotangent of alpha. For this right here, I'm actually going to multiply 1 minus cosine of alpha out to everything because I just don't want to deal with the fraction. So doing that will look like this. On the left side, it's just sine of alpha because 1 minus cosine of alpha would cancel. But on the right side, you have cosecant alpha plus cotangent alpha times 1 minus cosine of alpha. I'm sorry if we've already done this problem, but so now we got, let's see, cosecant alpha times 1. Let's see, that's going to be cosecant of alpha minus cosecant alpha. If we want to, actually, hold on, let me use the box method because one of my students did it last week, and I thought that was a great idea of how to handle these without getting confused as to what in the world is going on. So let's try that here. Let me use this box here. What I'm going to do is I'm going to put cosecant and cotangent on this one. So we got positive cosecant alpha, we got positive cotangent alpha, and we're going to have 1 and then negative cosine alpha as a part of our box here. So the key is diagonal by horizontal. We're going to multiply. So unit with cosecant alpha times 1 and cotangent alpha times 1. Boom. We have, let's see, negative cosecant cosine alpha. That's interesting. And then the other one, we're going to have negative cotangent cosine alpha. Now, for just a quick second, let's think about it. Cosecant cosine is really going to be negative cosine over sine, right? Because cosecant is 1 over sine. So basically, it's negative tangent. So what we're going to say here really is this going to be cosecant of alpha plus cotangent of alpha minus tangent of alpha. And this last one, cotangent is cosine over sine, right? And this times 1, basically times cosine, basically. So cotangent cosine, basically cotangent cosine, there's not much we could do about that. So we'll just leave it the way it is, minus cotangent cosine of alpha. Now, supposedly all of this is going to end up being just sine of alpha. So we need to kind of think about how we could get this. Cosecant of alpha is 1 over sine of alpha. Cotangent of alpha is cosine over sine. Tangent of alpha is sine over cosine. I made a mistake. I said that this being cosine over sine, I said this right here was tangent. It should be cotangent. And that actually helps a lot because because then these two middle terms get cut. All right. That makes so much more sense. All right, so we got cosecant of alpha here minus cotangent of cosine of alpha. All right. So that makes a little bit more sense. So now what we really have, we can rethink about it. So still doing the same thing. 1 over sine alpha minus cosine over sine. So this will actually be cosine squared alpha over sine alpha. All I did there, guys, was just turn cosine into cosine over sine and then multiply it by cosine. So in essence, we have 1 minus cosine squared over sine, because the denominators are the same, which then is sine squared alpha over sine alpha, which indeed is just sine alpha. So once again, just it's pieces to the puzzle. And multiplying out to get rid of the denominator is definitely a viable option here. For that last one, I'm actually not even going to mess with the other side. I just want to give you a different way to do it. So we're on problem 526. And what I'm going to do is I'm only going to mess with the left side. And what I'm going to do is I'm actually going to multiply by the conjugate. So if you have secant A plus 1, secant of alpha plus 1, secant of alpha minus 1 will be your conjugate there. And so since I'm multiplying by the conjugate, stuff's going to cancel, which is going to be really nice eventually, but we'll get to that. So we got tangent of alpha times secant minus 1 all over, this is difference of squares, so it's secant squared minus 1. Now we know secant squared minus 1 is just tangent. So what we can do now is we can say tangent of alpha times secant minus 1 over tangent squared. Now, at this point, you might feel like, okay, but not much has changed. What has changed though now is that we can cancel one of the tangents out. So we're left with secant minus 1 over just one tangent now. And I can break this fraction up. Note, I could not break the fraction up at the beginning because the denominator was the sum. If the denominator has only one term in it, you can break the fraction up. Because in essence, this is secant over tangent minus 1 over tangent. And we know secant over tangent, basically that's going to be 1 over cosine, and then times. Now remember, tangent is sine over cosine. So if it's in the denominator, keep, change, flip. We're going to do cosine over sine, which the cosines will cancel, and you're left with cosecant of alpha minus 1 over tangent is cotangent of alpha, and we have proved the identity. So both ways are viable. You could have just multiplied everything by secant of alpha and then gone from there. But both, like I said, both ways are viable. Problems 527 and 528 are not too bad. What I would do in 527 and 528 is see where you could factor something out and then go from there. So for example, for 527, on the left side, I would factor out cotangent of x secant of x, which leaves you with cosecant squared x minus cotangent squared x, which is just 1. So if you think about it, that's just 1, and cotangent, as we know, so this piece right here is just 1. And cotangent, as you know, is cosine over sine. Secant, as you know, is 1 over cosine. So if the cosines cancel, you're left with 1 over sine x, which is indeed equal to cosecant x. All right, I think you guys should be fine on those. 528 is very similar. 529, now you got fractions on both sides. So if you have fractions on both sides, one of the things you can do is just cross multiply. So in cross multiplication, I've got tangent squared x cosine x is equal to 1 plus secant x, and then this whole thing times 1 minus cosine x. I'm looking at problem 529 right now. Where should I go for this? I think I'm just leave this the way it is for now on the left side. But on the right side, we're going to have 1, and then 1 times you have negative cosine x, then plus secant of x. And then if you have, think about it, if you have secant x times cosine x, don't they cancel each other out? So that would just be 1. So we end up with negative cosine x plus secant of x, which isn't all that satisfying. I mean, what we could do at that point, eventually, I suppose, is you could say you could do negative cosine x plus 1 over cosine x, assuming that I've done everything correctly, which is a big assumption. But you can multiply everything by cosine on the other side, so you end up with cosine squared x plus 1. Oh, just multiply cosine by everything. So that's cosine squared x plus 1, and then on the left side, you'd have tan squared x cosine squared x, which if you think about it, tan squared would be what, sine squared over cosine squared, and the cosine squareds would cancel, so you're left with sine squared equals negative cosine squared x plus 1, which is an identity, right? 1 minus cosine squared. So you know what, sine squared equals sine squared x. All right, that last one, I would treat these as difference of squares or sum of squares. Honestly, I don't even think it's all that bad. I think we'll leave that as a challenge for you guys. So if you all get through lesson 2 today, you're being very, very good shape. And if you get stuck, please let me know. I'm here for you guys, and hopefully I will see you soon. Bye.